All right, so again, we see a lot of you. Oops, I did not take roll yet. I need to pause this, and we'll be right back. All right, now, for those of you who chose to write this down, and we're not walking up and down the aisles to see you need to write this down, we'd like to try to come up with applications that maybe makes sense to you. So maybe this masonry worker is just doing some remodeling. And when we say skids, okay, we're just talking about blocks of wood like this that might need to be placed underneath it, because I see, what do I want to say, outside of Mrs. Milbrandt's room, there's a pallet sitting there, okay? So it's important to maybe have these skids to maybe be lifted up off the ground. Then maybe a forklift can get its skids underneath there and then maybe move this concrete staircase. But in order to do that first, they have to get it up off the ground. So in this case, a masonry worker needs to place 2 blocks, it's supposed to say 2 blocks of wood, underneath a concrete staircase. So a large pry bar is used and 75 newtons is placed onto the bar. If the concrete resists with 825 newtons, how far must the worker move the bar if the resistance distance is 0.10 meters? Okay, so the final, I believe one of the final formulas that we asked you to write down was a linear one. Linear, we just mean straight in a line like this. Does anyone possibly remember what that formula was? I mean, it has some of the terms in here. No, not horsepower. Give you a clue. It's related. It's not the same as efficiency, but it has the same variables. So a resistance force times a resistance distance equals the effort force times the effort distance. Okay? That's why we say that they are related.
Wait, is that another formula?
Yes. It was, we had wrote down on Friday, and some of us possibly weren't here on Friday.
Oh, yeah, I was.
Okay? So now I think we can possibly relate that writing your variables down certainly helps, because for those of you, I would think we probably have, 15 formulas maybe? Somewhere around there. I would think that's got to be pretty accurate. Okay? So now, when you look at the labels, why are they so important? When you're looking at just the letter N. Because what is N labeling? It's labeling force. So if this is our formula, that helps us differentiate between one of these two, because we see 2 forces here. Now, by looking at this, we can go ahead and remember, every time we read the problem, we want to write down what we know. Okay, so if there are 4 variables in this formula, we have to know how many. You have to know 3 of them. Okay, so if this is effort force, effort distance, resistance distance, and resistance force, by looking at what the problem is saying, a large pry bar is used and 75 newtons is placed onto the bar. Does that sound like that is a resistance force or an effort force on that bar? It's certainly an effort force. So 75 newtons goes here. Okay. Then if that is our resistance, or excuse me, our effort force, then our resistance force must be what's left. If the concrete resists with 825 newtons, that goes for your resistance force, 825. Okay? So we've got one more number to contend with. And what is that? What distance is this? Because it's measured in meters. Okay, and it tells you that it's the resistance distance. Okay. So look at it like this. Okay. So one of the things that might happen this was one of your vocab terms. If we use this, what is this called? This is a fulcrum. This is called a what? It's called a lever. Okay? So one of the things that we see happening is which side moves the greater distance? This side or this side? The east side or the west side? Which one moves the greater distance? Certainly this side. Okay? So that must mean we're putting way more effort into that, which we are. So what we're trying to solve for then is how far is this effort distance going? Because the result is on this side. That is your, and notice we probably don't have to lift it that far because it's only moving 0.1 meters, which according to this would be, we just look at 10 centimeters here, okay? And then that would give us our, or excuse me, 100. And that's about the approximate distance that we're looking at. Okay. So now that you have everything wrote down that you know, and we have the formula, we just do what the formula tells you to do. And what is on the right side of our equation? What's on the right side? Okay, do we know this variable? Sure, 75. How do we know that? It tells us that right here. Okay, do we know the effort distance? No, because there's a question mark there. Okay. So what's on the left-hand side of our equation? It looks like a resistance force and a resistance distance. So once we have this wrote down, according to our formula, what do we do with these two numbers? Yeah, you're going to multiply them. So we have 825 times what? 0.10. Okay? So upon doing that, we take 825 times 0.10, and we get 82.5, which I suppose we could have just done the math and moved it over twice. Oh well. 82.50 equals 75 DE. Okay? So how do we get our effort distance all by itself? What function are we doing right here? And how do we undo multiplication? Yes, you're going to divide. By what? By 75. If we do that to the right side, what do we got to do to the left? Same thing. So our effort distance then is approximately what? 1.10. And that is what? 1.1 meters. Okay, so this is a new type of problem. I think there's maybe one or two of those on your paper. I think one of them maybe deals with a coworker maybe using a crowbar. Another one, a farmer swinging an axe or something like that. I think that's on your paper. Okay? So look at what the terminology is saying. What is meeting for resistance? If if we're talking about this farmer who's swinging this axe, when they swing like this, is that an effort force or a resistance force? If they are swinging this hard, that is an effort force. So then it's going to meet resistance in whatever it is you're trying to split, and then you might be given that variable then as well. Okay. Is there anything you would like to go over before your short evaluation tomorrow? Otherwise, let me ask you this. Is anybody having problems on this paper that is due today? Oh, I was just seeing if everybody's paying attention. No, it's due tomorrow. Whew, right? Well, okay, it got your attention, didn't it? Maybe it wasn't funny, but I'm laughing. But I know, right? Okay. In my estimation, it's probably inclined planes that students sometimes struggle with. So an inclined plane, that's a fancy term for describing this. Because what is this? Yeah, it's a ramp. Okay? So maybe, I don't know if the camera can quite catch that. Maybe just one side. But, yeah, inclined plane. Because when you are discussing an inclined plane, what are you solving for? It's related to this. Force is part of it. It's a fraction. Which means, okay, we're testing your physics knowledge here. Work output divided by work input. That is a really vague statement because we know what is the formula for work. Say W equals? No. Okay. I could have sworn I heard V. That's why I said no, that's not right. So, input. Does that sound like effort or resistance? That is definitely effort. So, if we take our effort force and our effort distance, and we break this down to a force and a distance, what does it look like we're solving for then? You're solving for efficiency. So these two equations, they're related. You might say, well, what do you mean by related? Heat and temperature are related. They're not the same thing. Electricity and magnetism, they're not the same thing, but they are related. Okay? So these two formulas, again, they're not the same thing, but they are related. So if you feel it's worth your time, we can go through an inclined plane problem, but I also don't want to waste your time. Going once. Yes.
On the packet, on the sheet that you gave us, can we go over a question, please?
Okay. Hang on for just a moment. Okay, so number 3 says this. Okay, what is the total weight of 15 passengers? And the cable car power rating is 17,825 watts. The distance is 135 meters, and the time to get to the top is 38 seconds. Okay. One of those numbers we do not use. It's just extra information. Does anyone want to take a guess? Well, not guess, but can anyone possibly look at that and say, I know what that would be? Why is 15 not utilized?
Because you're just saying how many classes.
It just means there's how many different people are in there. Because there could be adults, there could be teenagers, there could be toddlers, infants. They're all going to have different masses is what we're trying to say. Okay, so in this case, we've read the problem. The next thing we want to do is write down what? Write down what we know. Okay, so in this case, 17,825 is what? It's measured in watts, so that is a what? Someone told me. What is it? Yeah, it's power. Okay? Now, whether you put a smiley face line over it or zigzag, that's up to you. The distance is 135 meters. Okay? So what variable is that? Okay? There's also one other variable in there. What other? Yeah, time. 38 seconds. Okay. So since this has power in it, we could look at this distance and time and say that gives us a velocity. But is that what the question is asking for? No, it's not. Certainly not. Okay. So what we need to break down is this formula, the power formula, which is, what does power equal? Give you a clue. What goes on top of the fraction? Work, right? Because anytime we're measuring work, we divide that by time. Doesn't that give us power? Sure. Can we break this formula for work down any further? What does work equal? We just talked about it right here. What does work equal? I haven't heard it yet. Well, what happens when you multiply those two variables together? What do you get? Work, right? So, if we take force times distance, that is a type of work. Now, do we have this variable? Yes. Do we have that variable? Do we have this variable? Yes. And forces are measured in what? And newtons is also weight, correct? So what this is saying then, once you have this wrote down, what is the total weight of those 15 passengers? According to this formula, once you've isolated that, you have the total weight of those passengers. Okay? So, we've got 17,825. Well, we can rewrite that. Okay? So what goes on the bottom of our fraction? 38. Okay? How do we get rid of this fraction? We've done it since the last week of August. You cross multiply. Okay? So what is 1 times 135? What is 1 times f? Just f, right? Okay. So if we cross multiplied here, what do we do with those two numbers? Same thing. You'd cross multiply. Yes?
What does MA measure?
It's just a number. Just like horsepower. It's just a number. Doesn't have any label. Mechanical advantages don't have any labels. Horsepower does not have any label. Neither does efficiency. They're just numbers.
Wait, so is it a percentage though? What?
Efficiency is.
That's the only one that's actually.
Okay.
Some are just-
Okay.
Anna, for number 4, what did you label it? 5. Don't label. I just asked it. Okay.
Now you can bring it home. Solve for f. Nope. One more step. Okay. Anything else? Number 5. Number 4. Okay. While removing an engine from a car, what is the mechanical advantage? It should say if the work input is 2,500 joules and the work output is 12,500 joules. What is the mechanical advantage? Okay. Did you write down the formula for MA?
Work output divided by work.
Okay. Did you write that formula down? You asked the question. Okay, so what is your formula for that? MA, what's the formula for that? Right. So let me erase this. Okay, so then what it says is the work input is 2,500. Where does that go in this fraction? Well, that's what it is, but where does it go in here in this fraction? Yeah, on the bottom. So then what goes on top? Okay, well, I thought we were confused about this problem. Okay. All right, we're just trying to point us in the right direction. That's all we're trying to do. All right. I think that gives you a pretty good start. Anything else? Otherwise, rest of the time is yours. Going once, going twice. Sold. Okay, so problem quiz tomorrow. We'll just do a slight review on Wednesday. And then Thursday is, of course, our last day in here. All right, we will catch up to you next time.